Welcome to the Matsuura One Machine, One Process in-booth demonstration. I appreciate everyone's attention. I'd like to introduce a few people who will be involved and available for questions. Our partner in Minneapolis, Custom Mold and Design, Lester Jones, the Vice President and Chief Operating Officer, is here. He's using the machine in his shop every day, so good real-world experience. You can ask questions how they're implementing the technology and the benefits they're achieving. Also like to introduce our applications team with us this week, Josh Schust and Nick Mitchell, two application engineers. Raise your hand a little higher. There you go. Any technical questions you might have, something that I say that you want to get some further detail, feel free to ask them throughout the day. Again, appreciate the opportunity to present our technology. A little bit about Matsuura. Matsuura started building CNC machining centers in 1934. We're a third-generation family-owned Japanese company headquartered in Fukui City, Japan. The fourth Matsuura generation just joined the company last September. So we have that strong family continuance going. In the early 70s, they launched, we launched 5-axis CNC machining, and to this day are one of the world leaders in highly accurate 5-axis machining centers. To build on that technology and to embrace the innovation side of Matsuura, in 1999 we started developing a powder bed fusion CNC machining center additive hybrid machine. As is common in Japan, the development and initial launch was handled through them. And then in August of 2017, Matsuura Machinery USA built a showroom, a demonstration center, and started selling and marketing the LUMEX Series of hybrid additive manufacturing systems. 100% focused on the injection mold industry today. We feel the one machine, one process concept is certainly a benefit and can demonstrate a significant return on investment to very high-end injection mold making technology companies. A little bit about the process. It's a sinter powder bed fusion based system with a 45,000 RPM Maxia spindle, Matsuura's own proprietary spindle technology. We grow the part or laser sinter 10 layers at a time is our standard process, so 20 thousandths of thickness, and then we go in and machine that sintered material back to finished machine-like tolerances and machine-like surface finishes. All of the parts you see in our display cases are as produced on our machine and as they've come out of the machine directly without any post-processing. On the laser sintering side, our process parameters are designed and developed to achieve full material properties without a hipping or without a heat treatment process. As sintered, they come out at 36 Rockwell. It can be heat aged, 485C for 3 hours to a 53 Rockwell hardness. Perfect application, again, in the injection mold industry. Materials available are a Miraging M300, which is a European tool standard, a low carbon, high chromium content steel. We also have 316 and 17.4 stainless commercially available, as well as cobalt chrome, Inconel, and aluminum. The aluminum aluminum is a reactive powder, so it takes a option on the machine. The tool steels run in our standard machining center. We have a integrated LUMEX CAM software, which is constantly being improved and updated by Matsuura. We have a team of software developers in Japan releasing every 6 months a new version of the software. Most of the efforts have been around improving the machining and reducing the machining time. Our cycle time is about 1/3 sintering and about 2/3 machining. So because we're a machine tool company, that's where our focus has been and where we continue to make improvements. That's the machine and the technology. Now some of the applications, Certainly the biggest hype application is the application of conformal cooling to improve part quality, to reduce cycle time, and certainly a big return on investment. There's a white paper that's available to pick up, created by Custom Mold on a particular application, really detailing the possible return on investment in implementing conformal cooling. As you'll see some of these parts on the table, here's a plastic version of the conformal cooling in a die-cast insert. This allows the customer to heat and cool the mold rapidly to prevent the problems with heat shock. They used to use about 20 of these inserts every year, and now they use 2 per year. So the life cycle of the part has increased significantly. Again, because we're machining as we grow the part, we can get very fine detail without EDM. In a lot of cases, we can virtually eliminate the use of EDM for deep ribs and deep pockets. The other very exciting technology is because it's a dense part, we can control the density of the material by laser parameters. So we, in this case, have built a porous vent on top of this drill point. In application, here's the finished part. You can see that the ping pong ball will spin, so that acting as a vent. Probably the biggest demonstration of this. You can see the air coming through the porous vent. Imagine the implications for a silicone injection mold where you can shut off the parting line and still let the material vent right through the porous structure. If I turn the air off, this liquid won't leak through the vent. So keeping them clean and the longevity of the vents we're finding is very beneficial compared to other technologies that are possible. Lester, any practical application comments that you want to make?
We've been working with Matsuura on the LUMEX process for about 8 to 10 months, something like that. So we've been learning a lot. We really appreciate the partnership that we have with them as we work to develop the process and train our people. We spent a lot of time with their application engineers in our facility, which has been very beneficial, and producing actual cores and cavities. The white paper that Tom talked about, we've got examples floating around here. We put together a battery case. It was an existing tool in most of the applications that we've had. When we build a new mold, we don't have the opportunity typically to build it in a conventional manner and build it with the additive process. So we're taking existing tools that were built conventionally, building new components through the additive process to demonstrate the benefits of conformal cooling. In this particular study, we're able to take a part that had a 18-second cooling time and reduce that down to 10 seconds. So we took 8 seconds out of the cooling time cycle and actually improved the warp condition in the part. So we actually ended up making a better part and saved 8 seconds for every cycle. And through our calculations with the cost structures that we have in place, in about 85,000 pieces, we'd have that new core paid for. So it demonstrates the opportunity to really save some money and make those parts a lot more economical. I think we look at our business as trying to help our customers, the molders that use the tools that we build, to provide the best quality tool that will make the best quality parts and the most efficient processes. So the conformal cooling applications really allow us to get at both those things, be able to attack the warp and sink areas, those kinds of things. A lot of medical components will end up, an inhaler, as an example, may have some passageways that have some really bad plastic conditions where the wall sections are thicker than one would like. To be able to cool that and reduce the warp and sink that might occur in that kind of a part, and at the same time reduce the cycle time, really brings benefits to the end user by reducing those costs.
Thank you. I guess if you could come up with, or leave with one idea or one thought process of implementing hybrid additive, the one machine, one process, we believe the LUMEX Series addresses three major problems or major issues facing mold makers today. Number one, trying to find a skilled labor force. This machine uses a different set of skills that are more readily available, I would say, than a seasoned journeyman mold maker. We're having a very difficult time finding mold makers, especially in the Midwest. I know our president on the machining center side says we could sell many more 5-axis machine centers if we could supply a machinist with them. So this technology, one machine, one process, allows that issue to be addressed. It also addresses some efficiency issues. It's meant to run 24/7, lights out, and provide progress as you're sleeping. Again, another significant advantage. And then lastly, it makes us more efficient and more competitive for our customers, or for the mold maker customers on the molding side, as Lester mentioned, with the conformal cooling and the application of unique technologies that are not available in any other platform.